KV4000 Programming Movie 4.6. So in processing and in Java and in other languages, we have what are called events, and these are externally triggered, and they may be thought of as sort of interruptions to a program by, for example, a mouse click or a key press. And rather than having to constantly monitor every single key and every single mouse button, that would really slow things down. We just assume that none of them are activated until they are, and then the system will detect that for us and send a signal to the program to say, hang on, we have an event. Okay, and that makes handling events very efficient, because we don't have to constantly look at a load of different keys and say, are you active, are you active, are you active? We simply allow them to sort of interrupt the main flow of the program. So each event, and there are a lot of different types of events, so some are to do with the mouse moving, some are to do with the mouse clicking, key presses and so on. So each event has its own pre-supplied function, which we have to redefine or fill out if we want to handle that event. So in this case, the mouse pressed function, which is not the same as the mouse pressed variable, it's basically a function that's executed every time the mouse is pressed. So whenever the mouse is pressed, the system will call whatever is written in the mouse pressed function. So it's initially blank, and if you don't supply any text for it yourself, then it's essentially just empty. But you can redefine it to do whatever you want, and this allows us to nicely separate out the functionality in our program and only handle mouse presses in a self-contained function called mouse pressed. So rather than burying it in the middle of a big draw function, we can separate out the functionality so that it's dealing with the mouse being pressed, that is dealing with the flipping of the toggle switch, okay, is done only where it's actually handled. And this is very good software engineering practice, because it makes sure that everything's nicely spread out in a modular fashion, and it makes problems much easier to track down, and it also makes your code much easier to understand. So here's a new version of our algorithm. So here we've got the algorithm as before, okay, but we've added this additional section, okay, to deal with the bouncing flag. So as the mouse pressed function is called by triggering an external event, we specify it outside the main loop of the draw function. So if mouse pressed is activated, then we flip the state of the bouncing flag. So basically, if bouncing is currently true, then we set bouncing to false. Otherwise, else we set it to true. So we basically flip the state of bouncing depending on what it is to start with. And that's all we need, nothing else. So here's the full code, and it's quite long. It goes over 2 slides, so you can grab it from Blackboard. So you'll notice again how this time we follow very good software engineering practice. We use the constants, and this time we have a speed constant, and this is used to set the frame rate for the application. So you'll remember that draw is called over and over and over again, and this basically tells us how many times we want to call draw per second. So that just allows us to control the speed of the animation. But all of this, everything else is pretty straightforward. We've seen it before. But you'll notice how we set bouncing to true. So bouncing is a variable, a Boolean variable here, and we initialize its value to true in setup. So we say by default the ball is bouncing. Okay, and here's the mouse pressed function, which basically just says if bouncing is true, and this is shorthand. We could say if bouncing equals true, but we simply say if bouncing, and that's essentially the same as saying if bouncing is true, then set bouncing to false. Otherwise, bouncing must be false, so set it to true. Okay, so this just basically flips the value of bouncing whenever the mouse is pressed. So remember, mouse press is a void function. It doesn't return anything. It simply acts on the bouncing variable. So remember, this is activated whenever the mouse is pressed. Now we could just as easily say bouncing takes the value of negating bouncing, that is not bouncing, but we've done it explicitly here just to make it slightly easier to understand. And here's the draw function. So this section here is key in that we only move the circle and then do all the collision detection as before if bouncing is true. Okay, so here we've got a whole chunk of code which is to do with moving the ball and then doing the edge detection just as in before, but this time we surround all of that logic with this if statement and the curly bracket. So we basically say only if bouncing has the value true, only if bouncing is true, do we do all of this. Okay, the moving of the ball, the edge detection and so on. And then we close the curly bracket at the bottom later on. Okay, so you can see how we've got a big chunk of logic following this if statement which is only executed if the bouncing variable is true. Okay, and in this way we attach different sections of code within a function to the outcome of conditional statements, and this allows us to structure the logic of the code very nicely. So we've covered a lot in this lecture, and thanks for sticking with it. So we looked at constants and how they improve our code. We talked about conditionals and relational operators, and also Boolean operators and toggle variables. So we looked at external events like handling the mouse and how that can be done very straightforwardly. And I hope you've begun to see how we can start to build fairly sophisticated programs using a relatively small amount of functionality. But I think it's important that we think through our solution before we commit it to code.